Assalamualaikum and hi, my name is Amir Muzammil bin Roman. So here I'm gonna present about additional theory. Torsion occurs when any shaft is subjected to a torque. The torque causes the shaft to twist. This makes one of the end to rotate relative to the other. The shear stress is induced on any cross section. For the second, torsion testing is made on materials to determine the modulus of elasticity in shear, torsion yield strength, and the modulus of rupture. Next, the shearing stress at any point on a transverse cross-section varies directly proportional to the distance from the center of the shaft when a simple circular solid shaft is twisted. Therefore, during twisting, the cross-section is initially planar, remains a plane and rotates only about the axis of the shaft.
So, the objective for the experiment is first to find the maximum shear strain, shear stress and modulus of rigidity. Second, to obtain the relationship between torsional load and angle of twist for a full range of strains until failure.
So this is the result from our experiment. We have two specimens, which is brass and mild steel. We have to record the initial diameter in mm, initial test length in initial total length, final diameter, and final test length. So this is the data that we get from the experiment. This is for the brass specimen, and this is for the mild steel specimen.
So now I will talk about observation for the experiment. First, as indicated in figure 1, we set up the device. The torque meter was turned on so that the reading could be seen on the screen of the torsion testing machine. Mild steel and brass were used to make the specimen. The hexagonal socket were filled with each specimen, which was then tightened with the deflection arm. Each experiment angle of twist was measured using a 360 protractor scale and torque was measured using a torque meter with the hand wheel turned 19 degrees each time. As a result, we have 12 readings because the hand wheel was cranked continually until the specimen was fractured, which is a twist angle of 723.67 degrees.
So this is the calculation part. First of all, we have to find the polar moment of inertia for brass, which is the formula is J equal to pi over 2 multiplied by radius to the power of 4. So this is what we get, which is 5.16 multiplied 10 to the power of negative 11. So for the second calculation, which is shear stress of brass, torque multiplied by radius divide by polar moment of inertia that we get from the previous calculation, and lastly the shear strain. For the formula, radius multiplied by angle of twist in radian and divided by length. And for mild steel, we use the same calculation as brass, but we change the data according to the experiment.
For the discussion, number one, plot a graph of shear stress against shear strain. The left side is for brass and the right is for mild steel. Number two, determine the shear stress at yield point. To find shear stress, the formula is TR over J. Shear stress for brass specimen is 77.32 and for mild steel is 76.41. Number 3. Attach the specimen image after failure. Then compare and discuss the result for each type of specimen material. The left image is for brass and the right is for mild steel. Stress and angle used for brass specimen are higher than mild steel specimen. Angle for brass specimen is 723.67 and might steel is 240. Number 4, based on the final length and diameter, show the effect of torsional stress. Torsional stress is an important structural action that increases shear strength. For the brass, the effect of torsional stress makes the specimen long in width. For the mild steel, the effect of torsional stress makes the specimen long and smaller.
Hello everyone, my name is Dinesh Raju. My metric is AA201271. I'm going to conclude the torsion experiment based on our observation and the result we get during the experiment. I can conclude that there is a direct proportionality in the relationship between a torque applied and the angular deflection of any circular shaft. As the torque and force applied increases, the degree of the torsion increases depending on the material and the structure of the shaft. Hollow, frailer, and a shorter shaft are more subjected to torsion, hence having a greater angular deflection. Through this torsion level experiment, the high percentage error between the theoretical and the experiment value should be taken into consideration for more improvement and for the accurate results. Thank you.